everyone. Excellent time to be here in hot Texas. This is my first time here in Austin, so really privileged and happy to be here to talk with all of you about hacking the OSS supply chain. Now, I only have a few minutes, so I'm going to go through this pretty quickly. A lot of what I'm going to talk about today just amplifies what you heard from Brian. So I want to take a lot of this as a call to action to you, and we'll talk about that a little bit at the end here. First, I'm going to breeze through some of the most famous hacks that have happened that were all over the media, caused a bunch of issues. You heard Brian talk about Equifax. This was Apache Struts. This was a known vulnerability. We knew about it, didn't get it updated in time, and caused all kinds of problems. Actually, some statistics on that. $1.4 billion in cleanup costs, $1.38 billion in consumer claims. That was 143 million customers. Pretty big deal. Next, SolarWinds. We're tired of hearing about this one. I kind of feel bad for this company. Like Brian said, it's not fair sometimes when this happens, but you've got to watch, your supply chain. And this is what happened with SolarWinds. Someone got into their TeamCity server and replaced a binary after it had already been built and, ran amok with that. Log4Shell, again, another one. This was terrifying for all of us Java developers. All of us use this code. Just about every single system that runs any Java process had to be updated because of this. So all of these things scare us, terrify us, but it's just the tip of the iceberg, and it really has to do with paying attention to where our dependencies come from. Now, I've been a developer for over 20 years, so I know how this works. Especially when you're a junior, you sit down, you start working on a project, you're excited to get something up and running. The first thing you do is build your code. Well, where does that come from? Where does this stuff you're working with come from? Most developers work smarter, not harder, so we're going to take advantage of all of the open source projects and libraries out there for us to use. We don't like to reinvent the wheel if we don't have to. It's not efficient or economical for anywhere we work. So this is what we do. We go to public repositories and we collect these libraries that our applications depend on, and that's it. We pay attention to what we're writing, but sometimes we ignore the source where everything is coming from. Who do you trust? We forget to carefully consider where these dependencies are coming from and a lot of the default behavior of our package managers. So I'm a Java programmer. I use Maven Central all the time. This by default is, this is what Maven does. If you don't specify a different repository, you're going to be pulling things from Maven Central. Same with NPM, same with PyPy. These are all public registries, and I'm not saying they're a bad thing, I'm just saying that they have their purpose. There's a reason they're there. This is how we share our libraries, especially our open source ones. This is where we make our libraries publicly available for the rest of the developer community. They're important, and we need to keep them. But we also need to verify what we're getting. Just like when you go to the grocery store and you pick up a container of yogurt, check the date before you leave the store. Make sure that something isn't expired. This would be the same thing we need to do with our registries. Okay, we need to get serious about open source security. So every time you do any of these commands, you do a pip install, a go get, a maven fetch, what Dan Lorick said, this quote is attributed to him, you're doing the equivalent of plugging a thumb drive you found on the sidewalk into your production servers. Now, there's some history behind this. In 2011, the Department of Homeland Security ran a test to see just how easy it would be to get workers to infect their own computer systems. And staff secretly dropped computer disks, this was a while ago, and USB thumb drives in the parking lots of government buildings and private contractors. And of those that were curious, now how many of you, if you saw something like that lying on the ground, would you pick it up and wonder what it is? Yeah, all right, a few of you. How many of you would actually plug it in to see what it is? Yeah, so 60% of those people plugged in the devices into their office computers, and they were infected. Luckily, this was a test, so not that there was any damage done. Now, additional stat on that, if the drive or CD case had an official logo, 90% of those were installed. Because you just immediately trust it, right? This is what we're doing with our public repositories today. Okay, there's several ways attackers can get into your system. Some of these techniques are now known by name. I'm going to run through these really quickly. Let's talk about the dependency confusion attack. There was a blog written by Alex Burson this about a year ago. He put it on Medium, and it talks about how he discovered how you can kind of trick people into installing things they didn't intend to. These are package names. You might be familiar with what this file is and what this is about. This is all about, requesting the libraries that you need, and there's a mix here of internal library package names and external as well that are open source. Turns out that you can override these packages. So if you note here the version requirements, you just need anything, either the version that's specified or greater. And what turns out is the default behavior of this particular package manager is that if there's a later version available, pull that instead. Well, if this is an internal package and there's a publicly available package that has a higher version, guess which one you're going to get? You're going to get one you didn't expect, one you didn't even write. So this is pretty scary and caused a lot of discussion to start happening. This is that whole entire interaction in picture form. You've got your internal stuff below the red line, public stuff above the red line. Notice you've got the evil version out there that you can get. And then you get what you don't expect. Horrible things happen. And one way to protect yourself just from that particular type of attack is to pull in some kind of artifact management system to restrict pulling packages that are public, that are meant to be only pulled internally. This is very simple, right? It's just something that we need to pay attention to and be aware of. So this vulnerability has been around forever, but Alex did a really good job of describing this in detail. And there's a few other details. You should take a look at his article that he wrote. This was a lot of money. He made a lot of money in bug bounties, 130 grand. That's pretty good. That's a pretty good living for trying to trick people into installing things they didn't expect. Okay, let's discuss how PyPy works. This is the de facto public registry for Python. You can just install stuff with pip install. Anyone can add a new Python package to PyPy. That's the benefit of having a public registry. Anyone can add a package. All right? This is actually not just anyone. This is an employee of JFrog. He's an employee of our security team. And he put a package out there that once you install it, there's code that runs on the installation of a package. It opens up his website. So he just put this out there to make a point. Pay attention to what you're getting and what it's actually doing. Our research team does a lot. We've discovered close to 400 zero-day vulnerabilities in all kinds of packages. We do a lot of work every day to make that happen, make sure that we catch these and share it with the public. We scan for software supply chain attacks. We did this with Python and scanned about 300,000 packages. We got about 6,000 potential hits. This is one of them, or two of them. One steals your credit card information, noblesse. The other allows for arbitrary code execution, Pythagora. I mean, these seem like harmless packages, but we found them. Both of them obfuscated their code. It wasn't really obvious what was happening, but these had quite a few downloads and were pretty scary. How many of you use your browsers to save your credit card information? Yeah. So it's safe, kinda. Safe from other places on the web or other tabs in your browser or whatever. It's not safe from anything running on your computer. And there is a way to actually get to the database and pull that credit card information out. It's a problem. Here's some code to actually do that. So any of these packages that you're pulling in could be doing something like this under the covers. All right, here's another one. This is typo squatting. This is if you happen to forget that @Azure at the beginning, the namespace there, you get a completely different package. So pay attention to that. Turns out there's lots of that running around. We did find those. We found at least 218 packages. They seem to be more like of a test or a bug bounty or something like that, so thankfully no damages were done here. But each of these packages were uploaded by an anonymized user, so it wasn't even easy to find out who did these or how many others they might have done. We've done a lot of research. Our internal security team has found a lot of stuff. There's a lot of efforts in the community that are, that Brian talked about as well. He talked about Salsa a bit. This is a really good one because it describes in detail some of the weak points of the supply chain that we need to pay attention to. Check that out. Another one here is Persia. This is an open source project that was actually just formally introduced and launched about a couple weeks ago now. Check this one out. This is a way to have a distributed network. This involves having different nodes become trusted package registries, and you can have multi-node verification of source builds. So I'm going to speed through this. Persia, just so you know, is some background on that. It's a communication system that the Greeks had. It seems to be a very good metaphor for what we're doing with the package management, the distributed network. And there's also a few different ways that we do this with this project. It's an interesting use case for the blockchain technology because we do keep a ledger to keep track of any of the packages that have been uploaded or used in the system so that you are sure that you're getting what you are expecting. Okay, so the security war is going on. We need to pay attention. It's everywhere. The media is doing a great job of telling us when we've messed up. So this is a call to action to you. Get involved with these communities, with the communities that Brian talked about as well. Everyone needs to pay attention. And there's kind of an inflammatory quote that I found having to do with the thumb drives dropped in the parking lots. There's no device known to mankind that will prevent people from being idiots. So we need to pay attention. Pay attention to what we're doing and be aware. Take what you've learned here today, go back to your teams, share what you've learned, and let's take care of this problem. Thank you.